Welcome. So, today we're going to dive into this really weird contradiction at the very heart of the AI revolution. I mean, on one hand, AI feels like it's just this unstoppable force. But on the other, it has some truly bizarre, almost silly flaws. So we're going to ask the big question, are these large language models the straight shot to true artificial general intelligence, or are they just a very, very powerful detour?
Okay, so let's start with just how powerful today's AI really is. This isn't science fiction. This is happening right now. For instance, AI is already optimizing the logistics for huge freight companies in the US, cutting their fuel consumption by up to 10%. I mean, that is a massive real-world impact with huge economic benefits. It's smart, it's efficient, it's pretty much exactly what you'd hope for from a superintelligence in the making. But then you see the other side of the coin.
And then you get something like this. The AI critic Gary Marcus tells this story where his kids asked an image generator for a unicorn. Simple, right? But what they got was, well, a creature with two horns and two legs. And that's the whole paradox right there. An AI that can streamline a nationwide shipping network can't seem to grasp the most basic fact about a unicorn. It's absolutely brilliant and completely baffling at the same time.
And that really brings us to the central puzzle we're tackling today. How can a piece of technology that's so incredibly complex fail on what feels like simple common sense? You know, this isn't just a funny little glitch. It actually points to a much deeper structural problem in how these models think. So, to really get this, we have to change how we think about AI's mistakes. The industry has a name for them: hallucinations. It makes them sound like these random, unpredictable bugs. But what if they're not bugs at all? What if making things up is actually a core feature of how they work? And what if that feature is surprisingly similar to how our own brains work? You know, most of us have this idea that our memory works like a computer. You save a file, you open it later, and you get a perfect copy. But as AI pioneer Geoffrey Hinton loves to point out, that's not how human memory works. Not even close. Our memory is generative. When we remember something, we're not fetching a file. We are literally reconstructing the event. We're telling ourselves a story that seems plausible.
In psychology, there's a perfect word for this: confabulation. It's when our brain fills in the gaps in our memory with details that seem like they should be there, even if they aren't true. The key is, we're not trying to lie. We're just generating the most likely story. And guess what? That is exactly what large language models were built to do: generate the most plausible sequence of words.
And this is Hinton's big insight. When an AI hallucinates, it's not broken. It's confabulating. It's doing what a human brain does all the time: generating a plausible story without having an internal fact-checker. So in a weird way, this flaw actually makes them more like us than we thought.
So, okay, if confabulation is the what, we still need to figure out the why. Why are these systems so prone to just making things up? Well, the answer comes down to a critical piece of the intelligence puzzle that these models are missing entirely.
See, as humans, we walk around with what scientists call a world model in our heads. It's our gut-level, common-sense understanding of how the world works. We just know that gravity makes things fall, that people do things for reasons, and that unicorns have one horn. It's our built-in sanity check. LLMs, they don't have that. All they have are statistical patterns they learned from text.
And when you don't have that internal model of reality, the consequences are huge. The AI can't really reason about cause and effect. It can't tell the difference between something that just sounds plausible, like a two-horned unicorn, which isn't a huge statistical leap from a one-horned one, and what's actually true. Its intelligence is, in a sense, very shallow.
Gary Marcus has this perfect analogy for it. He says an LLM is like a blind pig that sometimes finds a chestnut. I mean, they're great at finding those chestnuts. They produce amazing, insightful, correct answers all the time. But at their core, they're still blind. You never really know if the next answer is going to be a brilliant insight or a two-horned unicorn.
So this leaves the whole field of AI with a massive question. If the current strategy, just making bigger and bigger language models, has this fundamental flaw baked right in, is there another way? Is there a path to building an AI that we can actually trust to get things right?
Well, a growing number of critics and researchers say yes, there is. And the answer might involve bringing together two old rivals in the world of AI research, two completely different ways of building an intelligent machine.
The easiest way to think about it is with the System 1 and System 2 model of human thought. Today's LLMs are all built on neural networks. That's your System 1. It's fast, intuitive, and amazing at spotting patterns. The other, older approach is symbolic AI. That's your System 2. It's slow, deliberate, and works based on hard-coded logic and rules. Now, what's crazy is that for most of AI's history, these two camps were basically at war. The symbolists were convinced that true intelligence was all about logic. Meanwhile, the connectionists, the folks building neural nets, believed it was all about learning from data. And each side thought the other was totally and completely wrong. Gary Marcus has this brilliant, colorful way of describing it. He says it was like a very bad marriage that ended in a messy divorce back in the 50s. But the new argument is that this old fight is holding back progress. And to build a truly smart and reliable AI, we need to get these two back together. And this big reconciliation has a name: Neurosymbolic AI. The idea is actually pretty simple but incredibly powerful. You combine the strengths of both. You get the fast, creative pattern matching of a neural network, but you pair it with the rigorous, fact-checking logic of a symbolic system. It's like pairing a brilliant artist with a meticulous editor.
So here's how that might look in practice. First, the neural network, your System 1, takes a look at the problem and makes a quick, intuitive guess. But, and this is the crucial part, before it gives you an answer, a symbolic reasoning engine, your System 2, kicks in. It checks that guess against a database of facts and rules. Does this make sense? Does it violate common sense? Only after it passes that check does the system give you a final answer. You get the best of both worlds, insight backed up by reliability.
So, where does all this leave us? Well, it gives us a whole new way to look at the AI boom we're all living through. Maybe this massive explosion of LLMs isn't the finish line. Maybe it's a powerful, fascinating, and incredibly useful detour.
So, here's what to remember. Those AI hallucinations, they're not really bugs. They're a feature of a system designed to generate plausible stories. This unreliability comes from a fundamental lack of a common-sense world model. That's why many critics argue the current path is a detour from creating truly trustworthy AGI. And the way back might just be Neurosymbolic AI, which finally combines that fast intuition with slow, careful logic.
Which leaves us with one final thought to chew on. Are we watching the birth of true artificial intelligence right now? Or are we just getting really, really good at using a powerful tool, whose own limits will force us to change direction entirely? The answer to that is going to shape the next chapter of our world.